Good evening. Welcome to the JDRF Minn-Dakota's annual Research Progress Summit. I'm Camille Nash, a volunteer leader with JDRF. I'm currently serving as the chapter board member, and I'm also the national chair of advocacy. Volunteer leadership is the key to success with our chapter. I hope you had an opportunity to visit some of the JDRF tables during the reception and learn more about the exciting ways to volunteer. Your packet also contains an interest form that you can complete tonight and turn in at the back of the room, or you can email it to the staff at mindakotas@jdrf.org. You have talents to share with JDRF, and we have ways to put those talents to work. Our JDRF chapter is made up of efforts in 3 states: Minnesota, North Dakota, and South Dakota. At this event, we are able to link up 2 of our sites, Minnesota and South Dakota, because of 2 corporate partners. With the support of Medtronic and Sanford Health providing technology, support, and space, we here in Minnesota are live linked with our friends in South Dakota. Join me in thanking our hosts, please. This year, we're also broadcasting the meeting to some of our constituents in Rochester through a partnership with Mayo Clinic. Next year, we hope to bring other sites online in Fargo and Duluth. We're also taping the meeting to make it available online to all of our constituents. We love the part of our chapter role that allows us to share the tremendous progress being made in diabetes research. Please remember, fundraising provides the financial support for research we all count on for a cure. It's also the reason we have the artificial pancreas in outpatient clinical trials right now. We also enjoy the chance to personally thank you for all of you do to make our fundraising a success and possible. Oops. Tonight you'll hear about JDRF's expanded vision, a vision based on the belief that there is a way to end diabetes, and there are steps along the way to make living with the disease easier, less burdensome, and less invasive. Tonight you'll have the opportunity to hear very specifically about improvements in diabetes management that can save lives. We have a very exciting evening planned. I will talk a bit more about JDRF's government relations and outreach programs, and from members of JDRF's research team tonight, they'll be speaking from Sanford Research Center in Sioux Falls. You'll hear about JDRF's plan to rid the world of diabetes and about some recent research progress in areas of autoimmunity, regeneration, and islet cell replacement. Then, Ton Brobson, our keynote speaker, will share his experiences living on the artificial pancreas for 3 days as part of JDRF-funded human clinical trial. We'll end with a call to action. We need you, and we want to share with you exactly how you can get more involved. But before we embark on all of that, we want to thank you for all that you're already doing to support the JDRF mission. Tonight is about showing you exactly how we're putting your contributions of time, money, and talents to work. While fundraising programs are a visible and important part of each JDRF chapter, advocacy is also important to ensure funding for type 1 research. We need each of you to be a JDRF advocate, to simply tell your lawmaker your own diabetes-related story and stress the importance of partnering with JDRF. It's very simple. You sign up as a JDRF advocate, you receive a text or an email message with a link asking you to make a phone call or type 1 or 2 lines asking your legislator to support type 1 funding. That's all it takes to be an advocate. These calls and messages are tallied in the lawmaker's office, and at the end of the day, the lawmakers take this information into account when casting their votes on diabetes-related issues. This December, JDRF advocates were absolutely integral to getting the Special Diabetes Program renewed at $150 million for the year. It was an amazing accomplishment. At the end of this year, we'll need to begin these advocacy efforts again to ensure another renewal of the Special Diabetes Program. Many important research programs are funded by the Special Diabetes Program, including the Artificial Pancreas Project. This project was jointly funded by JDRF and the National Institutes of Health through the Special Diabetes Program. Each part of the funding was essential to the success of the project. Another exciting JDRF advocacy program occurring this summer is the 2013 JDRF Children's Congress. In July, Minnesotans Emma and Anna Arntzen, Taya, Troy, and Tylee Olson from North Dakota, and Jack Kirsting from South Dakota will join 150 other delegates aged 4 to 17 from around the U.S. for Children's Congress. They'll visit our lawmakers in Washington, D.C. to ask them to support Type 1 research. But you don't have to travel to Washington to visit with your lawmaker. As a JDRF advocate, you'll have the chance to participate in another important JDRF program, the Promise to Remember Me campaign. JDRF families meet with their lawmakers in the district offices at home in their state. This is a chance for you to tell your legislator why a cure is important. And when the Special Diabetes Program comes up for renewal at the end of the year, your senators and congressmen will have promised to remember you when they vote. Your voice is powerful. Use it. Use it to help get a cure and a better life with diabetes until then. You'll find a form to sign up as an advocate in your packet. Fill it out, drop it off at the government relations table, or stop by the GR table and talk with our volunteers there. And please visit the JDRF.org site and click on advocacy to keep apprised of updated information. The JDRF Outreach Program is a resource for you at all ages and stages of dealing with diabetes. The program also offers a number of volunteer opportunities. Emily Green is the staff person you can contact to learn more about outreach resources, support, and opportunities. Emily and the Outreach Committee, Volunteer Leadership, chaired by Jenny Ray Wern, operate a number of different programs. Jenny Ray, can you stand up? Are you in here? Okay, I guess she must be outside. She has a beautiful watermelon-colored jacket on, so you'll see her outside at the outreach table. JDRF has several ways for people to get resources. Networking groups and the Mentor Program offer an opportunity to connect personally with others sharing your struggles with diabetes. The Bag of Hope offers tools for families who are newly diagnosed. Building on this program, JDRF has developed other toolkits for specific audiences to help people in their diabetes journey at all ages and all stages of the disease. We encourage you to consider sharing your email address with us so that we can keep you informed on a monthly basis with our e-newsletters for parents and adults with Type 1. In your packet is a form you can complete and let us know what is of interest of you. And again, don't hesitate to contact the office or visit our website to learn more. So tonight is all about getting you excited about JDRF's work and your work with us. You've just heard how much of an impact you have on our fundraising success, the money that drives that research, and how you can lend your voice to our advocacy goals. We need you now more than ever to drive our ever more aggressive agenda of improving lives and curing Type 1 diabetes. So now is the time to inspire you with research progress. Thank you for taking time to hear about our important programs. Now, please welcome Jackie Casey, JDRF Minn-Dakota's Executive Director.
Good evening, everyone. We're a full house, and we're even using the overflow space, so that is really, really exciting. Thank you so much for coming on a beautiful evening that we haven't had one in quite a long time, so I appreciate you being here. I was listening to Garrison Keeler last night, and he was saying that the weather was beautiful in Minnesota, and now we had nothing to talk about. So we're going to talk about something way more exciting than weather tonight. We are really excited tonight to be joined by two members of JDRF's research team. Tonight they will share JDRF's overall vision for how research can drive better treatments, one day a cure, and ultimately the prevention of Type 1 diabetes. They will also share some recent progress in some of the key areas. So what I don't have confirmation about is whether or not speaker number 2 is with us. So we may be winging this a little. She was flying into Sioux Falls, so we hope she's there. But for sure who's there is Dr. Patricia Killian, who is the director of the Beta Cell Regeneration Program at JDRF, where she develops and implements strategic initiatives to accelerate the discovery of therapies to maintain and restore beta cell function in people with type 1 diabetes. In the area of diabetes, Dr. Killian has extensive scientific and global management experience in both pharmaceutical and biotechnology companies. She has more than 50 scientific publications and patents. What I've always found so amazing about JDRF's own research team is that they are rocket scientists in their own right. They could be out there actually doing the research, but they've decided to commit their passion to helping us drive others to do the research. But they are super darn smart, and we are so fortunate to have them. We hope that she is joined tonight, if she was able to get there, by Dr. Julia Greenstein, who is the Assistant Vice President of Cure Therapies, one of JDRF's core research programs. Many of the projects in the Cure portfolio also contribute towards the goal of ultimately preventing type 1 diabetes. In her more than 20 years of experience in the corporate biotechnology arena, Dr. Greenstein has held various leadership positions that have helped accelerate discoveries to market. When they have completed their presentation, there will be time for questions. Please join me in welcoming, live from Sioux Falls, Dr. Greenstein and Dr. Killian.
Thank you, everyone here, and thank you, Jackie. Actually, Julia Greenstein at the podium to start. We switched orders on Jackie, and I guess she didn't get the message, so I apologize, Jackie. But what we're going to do is Pat and I are going to tell you about some exciting work that's happening in the Cure and Prevent portfolio. We'll take questions, and then Tom will be presenting from Minneapolis on the artificial pancreas work. So what I wanted to sort of briefly begin with is kind of how we're evolving JDRF's vision for the future, which is very simple. It's no type 1 diabetes. It's a world where normal physiology is restored and no one suffers the terrible impact of type 1 diabetes, its complications, burdens, and damages. JDRF-funded research efforts are creating the outlines of this world and helping it come into view. We know it's possible. We can't say exactly when, but we know that we will get there faster and by accelerating our fundraising and to continue building momentum in type 1 diabetes research. Until we get to a world without type 1 diabetes, we want less. And what does that mean, less until none? Well, what we've been doing is building a strategic plan for research funding focused on ensuring there's an ongoing stream of meaningful efforts underway to develop and commercialize therapies that lessen the impact of type 1 diabetes, keeping people with type 1 diabetes healthy and safe now until that vision is achieved. It will require substantial annual investment to reach this goal of living in a time when type 1 diabetes is spoken about in the past tense, just like polio and smallpox. The path forward is an expensive one. Today, JDRF has $530 million at work around the world advancing our goals, but that's not enough. The gap between what we have and what we need is significant, and we need your help to bridge that gap and provide a future for people with type 1 diabetes to meet the vision of no type 1 diabetes. So again, what do we mean by less until none? Less until none is our promise to progressively remove the impact of type 1 diabetes from the lives of those living with type 1 until it is no longer a threat to them or their families. We're going to do this by encouraging the development and commercialization of therapies that lessen the burden of the patient and the caregiver for type 1 diabetes care. We want those therapies to be less invasive to administer and to manage. We want them to be less complex and demanding, and we want to reduce the dangers and complications of current therapy practices. Less of everything that makes type 1 diabetes so challenging, so 24/7 in your lives, until there's none. That's the underlying theme of what we're trying to do in building a strategic research plan. So what we're trying to do is look at therapies on the way to a cure, and that means a continuous way to improve the safety, side effects, and potential complications to be better than what that came before. Our past investments have yielded significant advances, but they've taught us that there's no single eureka moment that will cause type 1 diabetes to vanish at once. It's going to be an incremental progress with a series of breakthroughs across different therapeutic approaches occurring on different timelines, and that cure may be different for many people in this room. The path to the cure is actually a continuum of therapies, and that's what we're trying to show in this slide. As the therapies move from left to right and get closer to the cure, the new therapies will continuously remove the activities that represent the daily patient burden of type 1 diabetes, side effects, and complications. As we move forward, we'll want to increase the delivery of therapies that control glycemia and restore glycemia on the way to the ultimate goal of normal physiology. JDRF is the only global organization with a strategic plan to bring that continuous flow of life-changing therapies and ultimately the cure for type 1 diabetes. So how do we do that? Well, we do that by funding research, but we do that in hand with our advocacy group. And you heard a little bit already this evening about how advocacy works with JDRF. And this slide is meant to show you the pipeline of development from basic research to actually delivering clinical options to patients. And you see it's not only research that drives that pipeline, but it's the combination of research and advocacy to proactively accelerate the discovery and development and delivery of drugs and devices to cure, better treat, and prevent type 1 diabetes. So how does JDRF do that? Well, we can't do it alone. We do it by proactively building partnerships with a vast variety of different types of organizations. We need basic scientists, we need academic institutions, we need corporate partners that are really going to bring these cures through the regulatory practice and into commercial reality. We need insurers and payers to be on board about the benefits of these trials and therapies. And so what JDRF is doing now proactively is building these partnerships for the future so that everyone knows what to expect. So what I'm going to do is very briefly touch on part of our prevention portfolio as well as our cure, and then Pat Killian is going to talk about regeneration. So what are we talking about in prevention? Well, that's really an approach to really stop type 1 diabetes from occurring and stopping it very early. Why do we want to do that? We've really not talked about that before, but the community has come to this understanding that the burden of diabetes is growing in a population sense. And this is relatively surprising, but if you look across a number of decades, and you can see the data from Finland goes the longest back to the 1950s, there's a huge increase year over year in the incidence of type 1 diabetes. And what that means is that basically the incidence of type 1 diabetes, new cases per year, is doubling every 20 years. And that's really surprising. It's not a change in the genetics. It's probably a change in the environment. We're trying to figure that out. But it means that the incidence is increasing, and what we need to do is stop this increasing incidence. So we're building a rationale for the prevention of type 1 diabetes. And what this graph shows you is if you look at the beta cells in a person's pancreas, and that's the beta cell mass on the y-axis here, and you look at over time, and everybody's time frame for the occurrence of type 1 diabetes is different depending on when an individual is diagnosed, but you start basically with 100% of the normal beta cell mass. And what we know is that we can start to identify people at risk by genetic risk and by environment, but those people still have normal beta cell mass. As the immune system starts recognizing the beta cells in the pancreas, the beta cell mass starts decreasing. And what you see is that we start to see signs of the immunology starting. We see autoantibodies. We start to see a decrease in beta cell mass, and we start to see some glucose intolerance. Those people are on their way to becoming type 1, but they don't get diagnosed until a point very far down on that line shown by the red arrow. And so what we're trying to do is look at two different ways to prevent diabetes. The first is called primary prevention, and that means trying to universally prevent type 1 diabetes with a vaccine. For example, the way we universally treat all kids now with polio or measles vaccine, to stop it before it starts at all, back when everything is still normal and the beta cell mass is 100%. The other thing we're thinking about is secondary prevention, and that means prevention after the cascade of beta cell stress and autoimmunity has begun. And that would be for people who are starting to show signs of autoantibody prevention. It wouldn't be universal, but it would be specifically for people that we know are starting to be on that downward curve of beta cell mass. And we're taking a number of approaches. Some of those approaches overlap our cure portfolio areas. In the primary prevention space, we're looking at viral vaccines. There's a growing base of evidence that there are enteroviruses that may be part of the key in the environmental triggers of type 1 diabetes. And so we've been working with scientists to try to do some epidemiology to actually repeat what's been seen in Finland, where they seem to see a certain percentage of individuals seem to get an enterovirus infection at the time that right before they're diagnosed for type 1. The other thing is we're starting to look at the microbiome or the microbiota. And what that means is that's all the bacteria in your normal flora. So there's about 1 million times more bacterial cells in your body than there are human cells. And that microbiota that seems to induce immunoregulation, and we're starting to understand that now. And so we're looking at ways where we could use that observation to establish a more normal microbiome that would cause the body to regulate its immune system in a different way. And we're also looking at beta cell autoantigen tolerogenic vaccines, and that's a big mouthful, but what we're trying to say is to use parts of the beta cell to induce tolerance. Many of you may have relatives or yourself have allergies, and you know about allergy shots where people can be desensitized against an immune response to cat or to ragweed. We're trying to use that same observation to desensitize individuals with type 1 diabetes, autoantibody positive people, treat them with some beta cell antigens in a particular way, and see if we can stop the autoimmunity that continues to cause type 1 diabetes. That might be useful in primary prevention, but it's certainly our primary effort in secondary prevention. And you see, so we do a lot of basic research that could be useful in a variety of settings. Until we understand better how to use these agents, we don't know whether they'll be primarily used for secondary prevention or potentially for primary prevention. And then we're also looking at beta cell survival agents in terms of their role in secondary prevention, and you'll hear more about that program from Pat Killian in a few minutes. So let's hop over to the cure portfolio, where we're trying to remove the daily burden of type 1 diabetes from those people who already have it. And so our goal is relatively simple. That is to achieve normal glucose control without the need to take insulin or to take immunosuppressive drugs. We have a variety of approaches, which you'll hear about, some of which you'll hear about tonight, on this efforts of beta cell regeneration and beta cell survival, so trying to keep a person's own beta cells either healthy or reproduce them. And then we're on the other side of the coin trying to replace an alternative source of beta cells with our encapsulated islet program, and I'll tell you a bit about that before Pat gets up here. And the result of that, the variety of approaches, some of which may work on some individuals and others may work on others, is to have people leading insulin-independent lives. And so why do we think about using encapsulated islets? Well, we know from the historical approaches of pancreas and islet transplantation that those kind of what is called replacement or transplant of islet cells can cure type 1 diabetes. This is a continuous glucose monitor plot of a person before they got transplanted with islets, and you can see there's lots of highs and lows all during the day. They have very high HbA1c. Post-transplant, that individual now looks totally normal, basically flat, totally controlled blood glucose post-transplant. This shows you that over time, at 2.5 years, and or at 3 years and at 4 years, that control of of normal glycemia is remaining in that individual. So that shows us that in the context of immunosuppressive drugs, which you wouldn't want to expose most healthy type 1 diabetics to, you can see that replacement of islet cells and controlling the autoimmunity cures type 1 diabetes. It's limited by two things. It's limited by the supply of healthy donor islets and pancreases and by the use of immunosuppressive drugs. So JDRF's portfolio is taking that, what we call proof of principle or proof of concept, that cell implantation can cure type 1 diabetes, and we're trying to make it practical for more individuals with type 1. So we're trying to take a therapy, which is transplantation, which is a limited applicability and has some serious risks to it, but it is a cure, and we're trying to change that to have an unlimited source of beta cells and something that would be safe without immunosuppressive drugs. And that's the primary way we're doing that is through our encapsulation portfolio. Now this shows you a little bit of science. I apologize for the technical nature of the slide, but let me tell you what it says basically very easily. We have a collaboration with a company called ViaCyte in San Diego. This is their slide, but we have been funding investigators for over a decade to try to take stem cells and make them into functional beta cells. And so this is a graph showing you that the differentiation of human embryonic stem cells, which are not, could become any cell in the body. What we've learned is the variety of signals one has to give them to tell them you really do want to become a pancreas and you want to become a beta cell. And we can do that in a culture dish. And so what ViaCyte has done through a series of changes in culture media over about 14 or 20 days, they can make these embryonic stem cells believe that they are pancreatic progenitors. They can't get them all the way to functional islet cells, but they can get them part of the way down that pathway. What they then found is if they take those cells and put them into a mouse, and they let that mouse just sort of hang out for about 3 months, those cells then get the right signals, and they actually turn into beta cells. And so the pictures of the histology show you on one side a ViaCyte embryonic stem cell-derived graft making insulin in the blue, and also making glucagon and somatostatin. They look like perfectly normal beta cells in comparison to a human islet graft in the other panel, which also makes insulin and is glucose responsive. It also shows you at the bottom panel in the graph that if we put those cells in a mouse, we can reverse hypoglycemia, and then if we take the cells out, the animal reverts to diabetes, and that just proves that the cells you added are actually the cells that are controlling the blood glucose. It's kind of a nice control to show that something else that you didn't expect didn't happen in those animals. So ViaCyte and a number of other organizations have cells like these. They're called pancreatic progenitors, and we think that they will be able to mature when they're transplanted into humans and become beta cells. Well, now we have to get rid of the problem with immunosuppressive drugs. And so what we have decided to invest our resources in is an observation actually that was made over 2 decades ago, and that is, can we find a way to put these cells in a shark cage? And so what you see here is a diver protected from the shark in a shark cage. And so if that diver were beta cells, and we could put those beta cells in a shark cage in a person's body, and could we protect them from the autoimmune response, which is the shark? So relatively simple, but it's hard to do. And so what we've done is we've been funding in this area for about 5 or 6 years. Very recently, we have initiated what we're calling our JDRF Encapsulation Consortium. It's a group of world-class scientists, bioengineers, chemists, immunologists, transplant researchers, and beta cell biologists, all trying to work together to solve this problem. Because we know that one scientist working in their field by themselves are not going to be able to pull this project off. What we need is a collaborative team in order to do this. So our goal is to have multiple parallel projects, all working towards successful encapsulation technologies. Investigators have been recently funded. The consortium actually was launched in March. We had our first consortium meeting. And although you can't really read the technical details of the groups that we have now funded, I wanted to give you a sense of the kind of structure that this consortium will drive. It's JDRF at the center, really pushing data and protocol sharing, cross-team comparisons, standardization, and perhaps supporting core facilities, which we don't have now. And then what we have is a variety of teams working on specific components of the problem of encapsulation. So at the top, we have work going on novel biomaterials. What should we make that cage out of? And how can we make that cage better? We're looking at macro device design, so not only what are the materials that go into the capsule, but how do you build a capsule to keep the immune system out, but to let the islet cells be healthy enough. We have to get a lot of oxygen to the islets to make sure they survive, and they also have to be able to sense glucose and make insulin, so there's a lot of technical constraints of what that capsule has to be. We have a team working on local immunosuppression, so are there modifications you can make to the materials to control the autoimmune response as well as the rejection of this foreign tissue. And we also have a team working on translational studies, which is meaning starting in the rodent, showing you can cure a mouse, an autoimmune mouse, an immunocompromised mouse, then going up the chain to larger animal studies to translate into the clinic. And we have some clinical programs as well in early stages. But I just wanted to give you a sense of the complexity of the consortium that we're building. Now, again, there won't be a quiz on this slide, but we're going back to the pipeline. Early discovery research, development of product ideas, getting things ready to go into the clinic, and then clinical trials. And this is a different way we look when JDRF scientists are working on managing the portfolio. We look at the portfolio in these ways to make sure that we've got sort of all the things covered that we know need to be put together in order to make a successful encapsulated islet. So each of these green bars is a funded research project. And what I wanted to do is show you Albert Waugh, who's the scientist in charge of this program, and the team has built this program, and this is the way we think about it. We think about it in the approaches that each of these scientists is taking. So one of the gaps that we identified is the lack of novel biomaterials. And so these groups are working in novel biomaterials, and you see that's mostly in the sort of early translational space. We know that we need an immunosuppressive strategy, and so you can see we again have translational work going on in this area, and we've got even a little bit going toward getting ready to the clinic, get to the clinic. This is local immunosuppression, again, mostly in the translational space. And then we do have translational studies. We've been supporting Living Cell Technologies in New Zealand, looking at porcine islets, actually, in an alginate capsule. And then we've got some large animal studies going on with some of the more novel approaches. But that's the way, when we work at JDRF, how we say, are we funding the right researchers? Are we covering the important questions? And are we getting to the end point? And that's how we balance the portfolio as we go forward. Our goal is to then have future versions of the capsule, which investigators like the ViaCyte team and like others are working on, will be much more sophisticated. So it won't just be a shark cage that physically keeps out the immune system, but we're looking at more active engagement where there'll be localized drug delivery. Some of the bioactive surfaces may act to protect the cells. We may add some helper cells and mechanical protection, as well as some oxygen generating, all coming into a multifunctional platform, which will then provide what we consider would be a second or third generation approach to allowing those pancreatic progenitors to mature in an individual and take over the daily burden of type 1 diabetes. So that's the overview of CURE from the encapsulation portfolio side. Pat Killian's now going to come up and tell you about regenerating cells from the individual who has type 1 diabetes in our regeneration program.
Thanks, Julia, and thank you, Jackie, for the nice introduction, and to everyone for inviting us here. It's a real pleasure to be here today and tell you about what we're doing in the regeneration program. So, a few key messages I hope that we can convey to you today. And we call it the regeneration program. It does include efforts to discover drugs to regenerate or form new beta cells. But it also encompasses drugs to promote function, health, and survival of beta cells. And I'll explain why we think that's important. So we're not just trying to form new beta cells, we actually want to maintain and promote the health of existing beta cells. And this is important so that we can actually address needs for all stages of type 1 diabetes, from prevention, as Julia talked about, to those at recent onset and established type 1 diabetes. Another key message is that, clearly this is really evolving and emerging area of scientific research, and it is a longer-term program. But we see clinical opportunities in the nearer term, and these have the impact for delaying disease progression and improving glucose control and metabolic control. And those are important in terms of avoiding complications and hypoglycemic unawareness, and we have opportunities like that exist today while we go on to achieve a full cure of insulin dependence. And again, just to highlight that at JDRF, we're really working to drive regeneration research and translation. And for us, our top priority here is to have clinical validation. So translation of academic research to clinical studies is our key focus. And we very actively are partnering in managing this pipeline of drug discovery and development. So what do we mean by beta cell regenerating and survival therapy strategy? So again, here in the green are what's a beta cell. So what happens in type 1 diabetes? The beta cells are lost. And what I'll explain right now, we're beginning to understand those mechanisms that are leading to the loss, and it involves a stress response in the beta cell. So if we can come up with therapies that will prevent that loss of beta cells, we would have a beta cell survival therapy. We would be able to maintain that functional beta cell in the person. On the other side of it, we want to be able to form new beta cells. So we call regenerating therapies. So an example would be if we could have a small molecule or a biologic factor that will actually act on existing beta cells to form new beta cells, which would be suitable for a person with some residual beta cell mass or before much is lost. But alternative are something we call neogenesis, which is forming new beta cells from other cells. So we're making a lot of headway on how to transform an alpha cell in the islet, which makes glucagon, to actually reprogram it or transdifferentiate to become a beta cell. Similarly, there may be progenitor cells in the pancreas that we can differentiate. Now, these progenitor stem cells, this is different than what Julia talked about, where the goal there is to be able to grow the cells in ex vivo or in a tube and then transplant in a protected setting. Here, actually, what we're trying to do is actually develop therapies working on the beta cell in the body with the person with type 1 diabetes. So these could be small molecules or these could be biologic factors. And then alternatively, another really new area that's emerging is that another explanation of why are beta cells lost in type 1 diabetes, to the right, we said this could be a stress response. Another option that's happening is that the beta cells, they start to get overstressed and actually will de-differentiate. They'll kind of go like into hiding. They just want to go into a protective mode. And if we can actually identify that mechanism and redifferentiate, we could restore functional beta cells. So there's been a lot of surprises in the past about 7 years that we started this program within JDRF. And one of the big surprises, for example, is that when studies have been done to look at the pancreas or the islets from people who have had type 1 diabetes, even for a very long time, this particular slide was something for an individual who had type 1 diabetes for 50 years, you actually find insulin-positive beta cells in the pancreas. not only do you find insulin-positive beta cells, but you actually find out that they're replicating, which is shown in the green. So this is important because while I think the old model was that, beta cells are just lost, the new model is really that the body may be constantly on its own trying to regenerate these beta cells, and it's more like a relapsing, remitting disease. So this is from a medalist study, and it's important for a couple reasons. One is that the people have had diabetes for 50 years. In a medalist study, you can find insulin positivity, and even if you could keep a small level of insulin-producing cells in the body, you actually can reduce the risk of complications and hypoglycemic unawareness, which is actually a very important goal. So there's been just a lot of changing dogma in beta cell research, and it's really spurring us to new therapeutic directions. So this one I mentioned that, there's insulin-positive cells. They're still present, even in long-standing type 1 diabetes. So what we want to be able to do is find drugs to promote increase in beta cell number. We also want to understand, how is it these cells actually escape autoimmune attack? Why aren't all the cells destroyed, right? They're not. So some are still remaining there. We want to understand those mechanisms. Other things that are important is that it was thought that, once you're born with beta cells, it's a fixed number, they'll never increase. And we actually are revisiting that now, and that's not true. We know that the number of beta cells will actually increase in response to metabolic need or in growing, in the young children, for example. So if, for example, in the mother in pregnancy, because the baby's growing and she's got increased insulin requirements, the beta cells will expand, and you can see an increased level in C-peptide, which will revert after birth. But even in women with type 1 diabetes, you see this increase in C-peptide. So if we could understand that process, maybe we could come up with a way to physiologically mimic this with other drugs. And then finally, another major change is not an all or none loss response in beta cells, but it may be more of a stress response, and that if we could reduce that stress response, we could actually maintain beta cell function and, as I'll explain in a minute, actually downplay the autoimmune response. So just to illustrate, this is similar to the chart that Julia showed where, functional beta cell mass is declining at different stages of the disease. Just to illustrate what we mean by survival therapies, we want to be able to prevent that loss of beta cells over time. And then with regenerating therapies, we want to be able to restore functional beta cell mass to a significant level. Now, in order to achieve these goals, things that would really help us will be to be able to get biomarkers of these different processes. So we actually have a lot of programs on biomarkers as well as attempts at being able to image beta cells. And then this is just a simple statement of our regeneration program goal, which is the program that Andy Rakeman and myself are responsible for. So our goal here is to discover, develop, and deliver therapies to promote survival, health, and function of beta cells, and to restore functional beta cells for all stages of type 1 diabetes. And we've got two product development efforts, the beta cell regenerating therapies, beta cell survival therapies, and then the closely aligned efforts to identify biomarkers of beta cell stress and health, as well as technologies to image beta cells. And the way we do this, it's similar to a pipeline that Julia showed. We really are working here to be able to take very basic research, advance it through what we call a drug discovery pipeline that you would find in any kind of a pharmaceutical company into clinical development for survival therapies, regenerating therapies, and biomarkers. So our goal here is basic research is on the left, and then we want to get to the right into the clinical studies to see if these are viable strategies. And we have a couple examples. Clearly, a lot of this is still at the preclinical discovery phase, but we have a couple examples here now of being able to get into clinical development, which I'll show you. So just as before I do that, two things just really quickly, how JDRF research is impacting two areas. First one is in beta cell replication. So again, when this program started, the dogma was, human beta cells don't divide, they won't replicate, and they cannot be induced. And then it was found actually, as I mentioned already, that human beta cells will expand. They'll replicate in young, obesity, and pregnancy in women. And the type 1 diabetes, the type 1 medalist studies, which I mentioned, actually showed there's proliferating beta cells. So we funded a number of different programs and collaborations, and scientists at UCSF, Stanford, Pittsburgh, and other universities have actually found the proteins that control beta cell division. And then they've actually identified those mechanisms. We work with other partners like the Genomic Institute and Novartis Foundation in San Diego. They did a huge drug screen of 2 million compounds, and they identified compounds actually that promote replication. And these are successful in animal models of beta cell regeneration. So we've got compounds. We've got to work to improve those. We have to improve the safety and the efficacy. The first proof of concept might be in a transplant setting, just to be able to show that beta cells can be expanded and transplanted. Ultimately, however, we want to be able to take these small molecules and into a clinical setting with systemic use as opposed to transplant. Now, another big area of change is in beta health survival. So here's a healthy beta cell. It responds to glucose. It makes normal process insulin. This little diagram. The insulin's a very complicated molecule. It's got to be folded just so. And it's a very tricky process for the beta cell actually to be able to produce this insulin. The old model was that the healthy beta cell in type 1 diabetes, you'd go to a dead beta cell, no insulin. So what we're really learning now, there's an intermediate stage. It's called a stress beta cell. And here, the beta cell is overcome by the glucose or high levels of glucose or other environmental triggers. It gets stressed out. It starts to produce insulin in an incorrect form. So it's inactive, it's misfolded. The more of this it produces, the more stress it puts on the beta cell. And this stress feedback loop actually will lead to the death of the beta cell. But not only that, it'll ignite the autoimmune response. So the thinking here is, it was always a focus on there's something wrong with the immune system. The thinking here is now there's something in the beta cell that actually may be igniting the autoimmune response. And if we could maintain that beta cell with a more normal function, we might actually have strategies then to prevent this disease from happening. And they're just to illustrate, if we can come up with a drug to relieve beta cell stress, restore beta cell function, and slow or stop the autoimmune response. And I want to mention, as I said, our goal here is to be able to the clinic. I want to mention the study that's ongoing here at Sanford Health with Alex Rabinovitz, which JDRF is helping to support. It's a combination study with 2 drugs that are used for other indications, sitagliptin for type 2 diabetes and lansoprazole, which is used for acid reflux, but at higher doses that actually leads to another hormone being secreted in the body. And so this trial is called the REPAIR T1D trial. I took this from clinicaltrials.gov, where a study is ongoing but not recruiting participants, which is actually great news because what it means is that all the participants have been successfully recruited, and the final study results are ongoing. I think we'll know the results in about a year. So we're very excited about this particular study. So the way we do it, I mentioned the partner with Sanford and JDRF, but really we have active partnerships with a lot of pharmaceutical companies, a lot of academics. So specific programs, research programs with Lilly and Sanofi and Johnson & Johnson. And really what we try to do in a lot of these cases is just shown by the logos for the different companies. So for instance, with JDRF working with Duke, UCSF, Lilly with the University of Geneva, Sanofi with Broad Institute, Eastern Virginia Medical School, University of Geneva. So we are acting like a bridge or a glue to bring these groups together. We need companies at the end of the day because they're the ones that are going to commercialize and market the drug. But we've got this great academic research and opportunity here to bring these groups together. So I think that actually concludes my part. Julia, you want to join me here and see if we perhaps have some questions, or I don't know how our time is actually running here. I want to make sure we give enough time for Tom.
Yeah, you're actually fine. We've got a couple minutes for questions, so I think in fairness to the Sioux Falls people, we'll start with them and let them ask questions since you're right there with them, Julia and Pat, and then we'll come over to anyone who has questions in the facility here. So can we do it that way? So Kara, does anyone have questions there of Pat or Julia?
There's a question here.
Nope.
So a person with type 1 diabetes, a person who has had type 1 diabetes for years and years more than likely has some beta cells that could be what you called not recapitulated, but living and rejuvenized?
Yeah, I mean, that's what it's pointing to. I mean, the levels may be very, very low, and they may be higher in others, but there's really sensitive methods now for detecting C-peptide levels. And I think now with these more sensitive techniques, you're able to find some level of insulin production in just about everyone with type 1 diabetes. But it will, that range will vary. And the more you have, the more you actually can have of that endogenous, or the body making its own insulin, the better it is in terms of avoiding hypoglycemic unawareness and also risk of complications. So even though we can't, where we want to get to is to have full functional levels, but at least even if we can improve upon that, it's going to have clinical impact.
I don't think we have any more questions here, Jackie.
Okay, great. Then we'll start in here, and then we'll move to Ross and in the other room. So does anyone here have questions, and I can give you a microphone? Sure. I'll just work my way back, so holler at me.
So I'm pregnant with our third child. Our first two have type 1 diabetes, and we saved our first son's cord blood, and we're curious about any research that's being done with extraction of islet cells with that cord blood, and any recommendations that you might have for this child and storing the cord blood.
So there have been studies with treatment of individuals with type 1 diabetes with cord blood, some of which have been JDRF funded, and we haven't had any results at this point that point to a way forward in terms of therapies using cord blood cells to treat either recent onset or established type 1 diabetes. We know that cords and other sources of stem cells can be used in similar ways that I talked about the ViaCyte work being done. So it is possible to make pancreatic progenitors from those cords, although the commercial interest at this time is much more to have an established cell source than to make, say, beta cells specifically for one individual with a given cord, because you still have the autoimmune response to deal with. So at this point, there aren't a lot of things going on in this area, but of course science changes and approach changes, so it's really a very personal decision that one has to come to about storing cords, and something you should talk to your physician about.
Other questions? Sure.
My wife is a long-term type 1 diabetic. Her brother also. And I'm curious about, they have such differing amounts of insulin needed on a daily basis. Does any of that relate to what you see in stressed beta cells, or what would be your remarks about that?
So what you're saying is that the insulin requirements are variable?
I'm saying that they're both on pumps, but to get within their target rates, their daily use of it varies drastically, barely amounts.
Yeah. Yeah, I guess there could be a couple of explanations. One could be that there is some level of insulin being produced, and then there also could be differences as well in how the glucose is being utilized, what the glucose control looks like, and how effectively they are metabolizing the glucose. So it could be at the level of the beta cell. It could be just getting better utilization of glucose that's there.
We're learning that type 1 diabetes isn't one disease, and we may have to treat it or cure it in very different ways depending on the kind of type 1 diabetes you have. The biology can be very different, and it's part of what we really want to do at JDRF is understand the heterogeneity of this disease, because we know that it's not one disease. It's not the same if you get type 1 diabetes when you're 1 or 2 years old compared to if you get it when you're 35. I mean, the immune system is in a very different space. Your pancreas is in a different setting. You know, it's sort of, you know, it's a catch-all definition of it's an autoimmune disease and you're lacking beta cell function, but we're starting to understand there are many diseases under that umbrella.
Let's do one more in here, and then we'll check with the people out in the other space.
I was really interested in the fact that you brought up long-standing diabetes, 50 years, still having beta cell regeneration possible. And I've been a type 1, not quite 50, 48 years. But I had my C-peptide checked in the 1980s when I volunteered for research studies at the Mayo Clinic and was told in order to qualify, you had to have a 0 C-peptide, which I did have. And then you brought up the fact that today there's probably more sensitive C-peptide tests available. So is it possible I still have some beta cells in me? That'd be awesome.
Well, yeah, I mean, you know, the studies that have been done, and certainly not everyone's been looked at, but with these more sensitive assays, they're actually able to detect some. So, you know, it's possible.
Okay, so we're going to...
variable, it'll be individual. Sorry.
That's okay, Pat, thank you. We're going to check with Ross out in the other room and see if we have any questions from that space.
Doesn't look like it.
Okay.
Oh, wait, we do. Hold on.
We have one? Great.
I got to get there.
Julia
Hold on.
and Pat are staying with us, I think, so even if you come up with some questions after Tom speaks, there'll be another opportunity.
Hi, my name is Salita, and I've been type 1 for 48 years. And I have a sister who keeps telling me about vitamin D. She goes, you got to take vitamin D. And I was wondering, do you do any kind of research, you know, like vitamin D levels of the body? Are they low in people with type 1 diabetes? I know there was something I read about multiple sclerosis. If you have low vitamin D, it makes it worse. And so I was wondering, any information on supplements and things like levels of the body?
There are a number of epidemiology studies going on where people are trying to look at the incidence of type 1 diabetes and how things like vitamin D or other factors could influence that. The NIH and JDRF support a study called TEDDY, which some of you may participate in, which looks at individuals at high risk for developing type 1 and is doing a huge epidemiology study. One of the measures will be vitamin D. There haven't been any reproducible studies showing an impact of vitamin D levels on the incidence of type 1 diabetes or on the ability of an individual who already has type 1 to, for example, have less complications or have better control. But those studies are very hard to do, so I think it's still a very open question.
Okay, I think we're going to go to the next presentation so that we can try to stay on time. But like I said, Pat and Julia will stay with us, and then they can kind of come back up when Tom is taking his questions in case we have extra questions. Pat and Julia, thank you so much for your time.
Thank you.
Again, I would just like to reiterate how fortunate we are to have such wicked smart people on our research team. Most importantly, they can actually speak to us in a way that we can understand what's going on. So you've had the opportunity to hear how better treatment fits into the big picture of how JDRF will one day cure diabetes. So tonight we're fortunate and have the honor to be joined by somebody who has actually worn an artificial pancreas as part of a JDRF-funded clinical trial. And the artificial pancreas is a key component of our treat portfolio. Tom Brobson is currently serving as JDRF's National Director of Research Investment Opportunities. He's been with JDRF for 8 years, and he's worn many hats. And he has become uniquely familiar with the JDRF research program without himself being a researcher. And most importantly now, by being a research subject. What I have always appreciated and loved so much about Tom is how committed he is, to ensuring that those who are impacted by diabetes know about the research, understand the research, and feel assured that their gifts and efforts are advancing the effort to cure type 1 diabetes. Since 2007, Tom has participated in multiple human clinical trials of the artificial pancreas systems, as well as human trials of new glucose sensing technology. Most recently, in the fall of 2012, Tom was involved in an early real-world testing of an artificial pancreas system being developed with JDRF support at the University of Virginia. Leaving the hospital setting behind for 3 days and 2 nights, Tom was able to go out to dinner and lunch and take long walks and explore the world with a smartphone-based artificial pancreas system, helped to automatically manage his blood glucose. Trials like this one are going on worldwide due to JDRF's generous supporters. Please join me in welcoming Tom Brobson.
And I'm going to stay out here, not behind the podium, if that works for the folks back there. Is that okay for me to be over here? I'm getting a thumbs up. So thank you. It's a pleasure to get to be here, and it's fantastic to think that I'm getting to be streamed to Sioux Falls and to Rochester. I was thinking as I was watching Julia and Pat Killian speak to us that I guess I never suspected the day would come that I would share a podium with people as impressive as the two of them. There's an expression that pebbles don't get to vote once the avalanche begins. And I really have to say it is people like Pat and Julia that get the avalanche started. It's their brilliant minds and their ability to look at things and find ways to do things that gets us where we're going. So what you're really hearing now, oh, thank you, is the guinea pig. So I'm really the pebble that's part of a much bigger avalanche, a much larger activity that was started by brilliant scientists just like Julia and Pat and many, many others around the globe. These particular group of scientists were all focused on artificial pancreas technologies and systems, and they've brought us to the point where, yes, last November, December, I got to walk around and have a real life on an artificial pancreas. So I'm going to talk about that this evening. I also will say I love questions, so I hope you will save your questions for at the end. And since we have so many different venues here all together, I think we're going to have to do the questions at the end, though I really usually like to do questions during a talk. I am going to try to cover sort of what is an artificial pancreas, when we got started with it, where is it now, and kind of what the future holds. I also am not a big lover of PowerPoint slides. I do believe in death by PowerPoint. It's way more interesting if we have a good conversation and that you guys think of things that you'd like me to answer. There are so many pieces, moving pieces, in just this one space of artificial pancreas. And we have just as many moving pieces in all of those things like prevention and encapsulation and regeneration that we just touched on. There's a lot here. So I'm sure I won't touch on everything. If you've got a question, hang on to it. Make sure you ask that question. So this does fall squarely underneath that treat area. I'm not going to spend too much time on this slide because I want to make sure we have plenty of time to talk about where we're going.